How can humans walk so naturally, stably and efficiently? Which are the key mechanisms behind this wonderful performance? These are the scientific questions behind the H2R project. What we know today is the existence of three main mechanisms. A neural mechanism by which the brain coordinates a very large number of muscles in a very compact, rapid and apparently simple way. A biomechanical mechanism by which the body uses the elastic properties of muscle and tendons to store and release energy during walking and to absorb shocks. And finally, a cognitive mechanism, which is the ability of the brain to understand the external world and to decide how to interact with it.
We team up with 6 different institutions in Europe to create a humanoid platform that integrates these 3 human mechanisms. That's why our project is called H2R, which stands for human to robot. What we expect from this integration is that the robot will show a more stable and versatile performance. In our mind, our robot was a kind of Pinocchio, the famous puppet that wanted to appear and behave like a human. This analogy fitted so well with the objectives of the project that we soon decided to call our future biped Pinocchio.
After 2 years of designing, drawing and manufacturing all the mechatronic components, and after more than 50 technical meetings between all the partners involved in the project, we can finally say, Pinocchio is here.
When designing the mechanical structure of Pinocchio, we tried to have a good compromise between mechanical simplicity and similarity with human body. We have taken into account human proportions, weight distribution, number, and range of motion of the different body joints. Our partners from the University of Brussels designed an actuation that was powerful and at the same time flexible as human muscles.
As for the electronic system, we want to reflect the structure of the human nervous system. For this reason, we designed a network composed of one central computer and several distributed control boards. The central computer is the brain of Pinocchio, while the distributed control boards resemble the role of the peripheral nervous system, a link between the brain and the actuators.
Pinocchio is a 21 degree of freedom biped. All the degrees of freedom have been designed to allow Pinocchio to have great flexibility, to perform most of the movements required during human-like walking. The lower limbs and the trunk are mostly made of aluminum and steel. The upper limb is made of wood and is composed of passive shoulders and elbows. Other parts, such as the head and the aesthetic covers, are made of 3D printed materials. Pinocchio has also a distributed sensory system that resembles that of humans. It includes a vestibular system placed in the head, proprioceptive sensors within each joint, and cutaneous sensors in the feet. This sensory system is crucial for the processing and compensation of external disturbances, such as unstable terrain or external pushes.
So far, we have included all the biomechanical principles needed for human-like walking into one robotic system. Now, the next step will be to give a soul to Pinocchio. The 3 German partners are working hard to integrate all the required neural and cognitive mechanisms. In particular, the Göttingen partners translated the walking control models observed in humans into robotic control principles. The Freiburg partners have been working on reproducing the human cognitive processes for balance and tested them into existing robotic platforms. Last but not least, the partners for Kaiserslautern have developed the main control framework, able to host all these mechanisms into one artificial intelligence scheme. This integrated scheme has been already validated in simulation environment and is now waiting to be tested into our real Pinocchio. In conclusion, we are really close to see Pinocchio standing and walking on his own.